Welcome to my second tutorial on subnetting chart table. If you prepare for a Cisco exam like CCNA, or if you're an IT student and need some better understanding of subnetting, this video is for you. But you must know the basics of networking protocols, especially IP version 4. So you must know what an IP address is, and you must know its structure, for example, what an octet is. If you don't, please learn those basics first and then come back here to watch this video. The first introductory video explained briefly how to increase the network portion changing the subnet mask, or in other words, what is the relationship between the subnet mask and the network and host portions. This video shows you how to draw and use subnetting chart table. It's easy to do. Just follow me and soon you'll become a subnetting master. So let's start. Okay, we're going to draw the chart table. First thing we're going to do is to write down the decimal values for each of the bits in the octet. And so, first value is 128, second is 64, third one is 32, fourth one is 16, then 8, 4, 2 and 1. Once we have all the decimal values for the bits within the octet, we write down our borderline. You remember our imaginary borderline between the network portion and the host portion. This is it. Once we have it, we write down the subnet mask insider notation for class C, which is 24. And now remember borrowing the bits from the octet. Alright. Now we write down 25 because we borrow one bit here. We write 26 here because we borrow 2 bits. And so on. 27, 28, 29, 30, 31 and 32. And now we're getting to the point. What is the subnet mask value in dotted decimal notation? For /25, it's 128. For /26, okay, it's not 64, it's 128 plus 64. For /27 is 128 plus 64 plus 32. So, to make the things easier, I'm going to write down another row of values. These values will be sums of the following values from the octet bits. And so, in first place, we have 128. In the second one, we have 192. Because 128 plus 64 is 192. In the third place, 192 plus 32 is 224. 224 plus 16, 240. 240 plus 8 is 248. 248 plus 4 is 252. Plus 2, 254. Plus 1 is 255. Alright, now we have all the values written down for class C. How to use or how to read the table now. If you have example of /25 subnet mask, that means that if you look up here, you read 128. So it becomes, remember, we're working with class C, that means this is the last octet. So we would have 255.255.255. Remember, this is our borderline. And now 128. If you had, for example, 29 in insider notation, what it is in dotted decimal notation? Simply look up here what it is. It's 248. So write it down in the last octet, as we're working with class C and we have 24 bits already assigned to that class. So first 3 octets would still have 255.255.255. And now different example, if you had, for example, given the subnet mask in dotted decimal notation. A subnet mask of 255.255.248, and you want to find out what it is in CIDR notation, you simply look down and you find out that it is /29. Alright, now let's complete our table for class B and for class A. In class B, you remember the subnet mask was 16. So adding one more bit would be 17. Adding one more bit would be 18, and so on. So we can simply and easily fill out our table 23 and 24 for all the classes. For class A, the subnet mask was /8. So the next one, adding one bit, is /9. Adding another one is /10, and so on, /11, 12, 13, 14, 15, and 16. And now an example from class B. Remember, class B uses 16 bits for the network portion. So if you are borrowing bits from the host portion, now you're jumping from the second octet to the third octet. So the numbers we'll be working with appear in the third octet, not in the fourth octet like in class C. And so, for example, let's take /18. What it is in dotted decimal notation? Definitely we use 2 octets. So 255.255 dot, now we are in the third octet, which will read 192 and put it into third octet, and then we have 0. Another example, /22. /22 gives us 255.255. Now we're jumping from the second octet to the third octet. We have, looking up, 252. So we're writing down 252 and now 0. We can work this out in the other direction too. For example, if you were given with a subnet mask 255.255.224, this one, and 0. How do you know where to read the values from? This number appears in the third octet. We know that class B uses 16 bits, which are 2 octets. When you add some more bits, you're jumping to the third octet. So you need to read this row, this line, in order to get the values from the third octet. So what it is then? In third octet, for 2 to 4, it's /19. And last short example from class A. If your subnet mask is 255.240.0.0, we know we are in second octet. Class A, its first octet, it jumps to the second octet, so we know we need to read the values from this line. So for 240, this 240. Our value in this line is 12. So /12. And we know that 12 is between 8 and 16, so it must be the second octet. The same in other direction. For example, /13. What it is? /13, I'm looking here, I found it. Looking up, it's 248. In which octet? In second octet. So it's 255.248.0.0. Okay, you might think that we have completed our subnetting chart table, but I'm going to show you something more, actually something that makes this table really useful, really useful. Okay, I have my table cleaned up, so you can see only the numbers, only the values. And the question is, how big are those portions, those smaller subnets? Where do they start? Where do they end? Because once one subnet ends, the next one right after it starts, and so on and so on. This chart table shows you all those values. Alright, let's take an example. A network 192.168.10.0 and let's say /26 subnet mask. We know that subnet 0 will be at 192.168.10.0. How big is this subnet? Where it ends, where the next one starts? Okay, let's look at the table. We have /26 here. Now we're looking up at the top row. 64, number 64 tells us that the next network, next subnet will start at 192.168.10.64. Where the next one starts? Again, we need to add 64. So 192.168.10.128, because 64 plus 64, this 64 gives us 128. Sometimes the values from the top row are called steps or magical numbers. Why? Because, for example, here we have 64, which is a step between first subnet, and a step between the next subnet, and a step between another one, and so on. Let's take another example. 192.168.10.0, but different subnet mask. Let's say 20. Okay, we're looking for 20 in the table. Once we found it, we look in the same column but the top row. We find number 16, and the 16 now becomes the step between the subnets using this subnet mask. So we need to add 16, another 16 for another network, another 16 for another subnet, and so on. So remember, we're working within one octet here. These values don't change. Only these values change for the subnet mask. So 0, 16, next 32, next 48. So these are subnet addresses, subnet values that use /20 subnet mask. And here's the final result, our subnetting chart table, nice and clean. I hope you'll find it useful and easy to use. If you like my tutorials, please leave comments and hit the like button. And thank you for watching my video.